Welcome back. I'm Tim Modise, and thank you for being with us this evening. And you can participate in our conversations on Twitter, and the hashtag is the Modise Network. Scientists around the world are expressing concerns about the Earth heating up, and this follows unusual weather patterns, especially in the northern hemisphere, where heat waves were experienced with wildfires breaking out in Sweden, the UK, and the US. These were matched by torrential rains that hit East Asia, with flooding that claimed dozens of lives in Japan. And here in South Africa, we've already felt the effects of climate change with water shortages in the Western Cape. In fact, South Africa is experiencing water shortages due to the drought that we are in currently. Even though we are experiencing these phenomena, many people believe that it is a natural cycle that will revert to the old cycle of summer rains and plentiful water. The scientists, however, insist we are headed for trouble in South Africa and in the region. What is going on with the weather? To discuss this and also for us to understand and come up with ideas and solutions, I'm joined by the University of Free State Water Strategist, Professor Anthony Turton. Pleasure to catch up with you again, Prof.
Always a pleasure to be with you, Tim.
And this topic will not go away, right?
We will become very old men, it will still be there.
And I've been watching these reports that I've referred to, and I thought of you, and that for years you've been active trying to educate us about the climate change and the effects of a whole number of things on the weather patterns. Now, are we in the middle, or rather, let me put the question this way. Is the world or planet Earth getting hotter?
There's very little doubt from a scientific perspective that this is happening. There's a huge amount of consensus in the global scientific community. There are one or two denialists out there. And the funny thing is about a denialist is they simply force the scientists to go back and improve on their mathematics.
Yeah.
So they get the answer more accurate. But the bottom line is that we are not only getting hotter, the structure of the gases in the atmosphere are changing. And I'd actually like to expand on two of those if I can, because while we are very concerned about large fires and large droughts, sometimes it's the small things that are very close to us that actually are also more important.
Such as what?
Well, because the climate's getting warmer, a couple of things are happening. Firstly, a country like South Africa that's very water constrained, we have lots of dams. Therefore, our dams are a major strategic natural resource. Our entire economy depends on them, but now the dams are getting warmer. So with the dam getting warmer, we're now feeding into those dams lots of nutrients, lots of effluent, sewage, etc., etc. So what happens now is they're little single-cell creatures in the dam, and what they do is they start capturing carbon dioxide, so the C from carbon dioxide,
yeah,
and the N, the nitrogen from the atmosphere that we breathe, and in the presence of water, hydrogen and oxygen, and those four elements come together and they form a potent toxin that is now starting to become an issue. As we speak right now, it's a major issue in Florida, in America.
Yeah.
And because the global consensus is that the planet can survive a 2-degree increase, interesting work done in South Africa suggests that we might have as much as a 5-degree increase.
We can survive that.
Well, we might not be able to survive the 5 degrees. So while we're talking about these big planetary things out there, things that are happening, big fires and big floods, etc., we mustn't lose sight of the fact that it's actually the small things at home. It's the toxins in the water that are coming as a result of climate change and other things. Those are the things we must worry about.
Oh, well, in the South African context, where is this happening? I saw a report recently about the Vaal water system, for instance. I'm not sure if it's got to do with what you mentioned, or it's got to do with effluent being allowed into the Vaal system.
Well, with all of these disasters, you get a confluence of a number of factors coming together. So in the case of the Vaal system, it's about failed municipal infrastructure. But the failed municipal infrastructure is simply accelerating something that's already underway. And that is it's a technical process known as eutrophication. Eutrophication is the enrichment of rivers and dams with phosphate and nitrate. And that causes this proliferation of these algae, these single-cell creatures called blue-green algae. They're known technically by the name of cyanobacteria. And the word cyano tells us that they produce a cyanotoxin. And cyano means C for carbon from the greenhouse gas, and N from the nitrogen that we're breathing in. Our air is 80% nitrogen, and these cyanobacteria link the carbon and the nitrogen to form cyanide. Cyanide is CN, and a derivative of that now in the presence of hydrogen and oxygen. And this becomes a toxin known as microcystin. And within the microcystin, there's an active ingredient, a very potent little molecule. I won't go into all the chemistry of it, but you know, the important thing is that it's these small things that are affecting us in our everyday life that we mustn't lose sight of the fact that it's...
But let me take you to the Northern Hemisphere for a while, right? Because for a long time, we know the climates, the Northern Hemisphere to be relatively colder compared to the tropics and the southern part of the world, right? That Europe, Sweden, I mentioned it earlier on, is a cold part of the world. And for them to experience the fires that they did recently was somewhat strange.
Yes, you know, we need to understand, once again, some very basic things here. So planet Earth has to transfer energy from one part of the planet to the other. There's a massive energy transfer system. And one of the ways that this energy is transferred is in the atmosphere itself. But a very, very important component of the energy transfer system are the ocean currents. Remember, the Earth is 2/3 covered by ocean. Yeah. So what happens in the ocean currents, how the oceans move nutrients around, how they move temperature around to stabilize the planet is very, very important. And this is driven by two things. It's driven by salt levels, the difference between fresh water and salt water. So the Amazon River bringing fresh water into the ocean, or the Congo River bringing vast quantities of fresh water into the ocean. That's one of the drivers of the so-called conveyor belt. And then the other one is temperature differential. So when your ice starts melting up in the North and South Pole, what happens now is these mechanisms are interfered with, and the transfer of energy at planetary level now is changed in quite a substantial way. So we're living in an intricate, almost a living organism. Earth is a living thing almost. And we're fiddling with lots of little things here, and we're starting to get to a point where just a colleague of mine recently in Sweden, a highly credible scientist, has recently published a report where they're talking about reaching that point where we've got feedback effects that's out of control.
Now, let me mention several places at the same time, and you try and pull them together for me. There's a drought going on in Australia as we speak.
Yes.
South Africa, we are in a drought situation of sorts, even though we don't say so openly, and I wonder why. You can tell me. And we've seen the fires going wild in the United States, California specifically. Yes. You've referred to what's going on with the ocean system in Florida, United States, and of course what we've seen in Japan that I referred to, as well as the UK. Pull all of this together. What actually is at play here?
Actually, there's a thing called El Nino, La Nina, and this is about a change in the surface sea level temperature over the Pacific Ocean that changes the volume of water that can be evaporated off the ocean into the planetary system. We are all linked by this El Nino La Nina event, and in particular, the areas that you've mentioned now, with the exception of Florida, they're all winter rainfall areas. So the winter rainfall areas, there are 5 in the world, of which Cape Town is one. I'll be over next month, I'll be in Melbourne, Australia, working with their people on strategies around this very issue. So it's the winter rainfall areas that are being felt more acutely, and this, of course, is the South African case with the Western Cape.
So, as we try to deal with this, what are the governments doing? Because there's been arguments about signing the Paris Accord. I'm not sure specifically what is it that needs to be agreed to that may help reduce or mitigate the problem.
I think the important thing is that we need to cooperate. We need to work in an international framework, because these problems are too big for any single country to solve. The sad thing is that America has pulled out of the climate agreement, the Paris Agreement. The good news is that individual companies and individual cities in America are still continuing in that same agreement. So it's very important that we believe in the scientists. Scientists put credible models on the table, credible solutions, and ultimately it's in our vested collective best interest that we cooperate over this water issue. Well, not only water is a subset of the climate issue.
But then, when we talk about it, we leave it to the governments, right? We forget that individuals have got a role to play, but also industrialization is being blamed for the faster pace at which the climate is changing. That, you know, it's as if before everything was okay, and it is because of the accelerated industrialization of the past 50 to 100 years that we have these problems. Would you associate it to that?
There's an ongoing debate driven mostly by the denialists about the human impact on climate change. What you get is you get a natural variability in the climate. And that's a natural signal that happens with or without human intervention.
I want you to explain that for a moment.
Well, because we're dealing with a complex system, and a complex system has got multiple variables. So let me give you an example. The first part is that the Earth moves around the sun in an elliptical orbit. So when we're closer to the sun, it's hotter, and when we're further from the sun, it's colder. The Earth spins around its own axis. So therefore you get day and night. And because the Earth has been tilted at a certain angle off the axis, you now get winter and summer. But the Earth's got a wobble on its spin, so sometimes you get variations on that. Then, of course, in that whole cycle, you get the lunar the lunar variable every 28 days. We've got high tides, low tides, etc. But then on top of that, you get solar winds. But every 7 or so, 8 years, you get these solar storms on the sun, and they send out massive amounts of energy into space. So all of these things come together, plus a lot of localized conditions, and you ultimately get what's known as a chaotic system. So there are so many forces at work here that there's not one that dominates over the other. So this becomes a thing that's very difficult to predict, and that's why the models can never give a definite answer. They can give an upper and lower limit of certainty.
Okay, which then leads to probably or strengthens the argument of the denialists who would say, you know, Anthony Turton, why are you bothered about this? Because it's beyond your control. But there are parts of climate change that are within human control, I suppose. And we'll pick up the conversation in a moment. I'm talking to water strategist at the University of the Free State, Professor Anthony Turton. And of course, there's a lot of stuff going on out there in the climate of the Earth, and it seems like it's getting hotter and hotter by the day. Is there anything that humanity can do to reduce or stop this? We'll find out when we return.